Okay, in this video we're going to be talking about the Goldilocks triangles, so mama, papa, and baby triangles. Okay, so if I took a flashcard and I cut them like this, okay, you can see we cut down these spots here, and then we got 4 right angles, and then there's a right angle down here, but you can't see it. Oh, yeah, I screenshotted it off. Okay, and we're going to be calling them mama, papa, and baby. So if you look, you can see that all the triangles are similar. So if we were to label them, we would label them papa because it's the biggest, mama's the medium, and baby is the smallest. You could see that all 3 triangles, if I put them on top of each other, are similar, meaning they have the same number of sides. All the angles should be congruent, and all the sides should be proportional. So you can mark all of the angles that are consecutive to each other congruent. We got the right angles, we got the top points, and then we have these corners here being congruent. Okay, if we were labeling the triangle, hypotenuse always sits directly across from your right angle. We also have the long leg, and if we have the long leg, we also have the short leg, so the smaller leg. So if we put it all in one flashcard and put it all together, it would look something like this. So they can be moved around, but they are still similar with consecutive congruent angles, and then long legs and short legs. Okay, so how these are similar to right triangles, they're all going to be right triangles. Okay, so here's an example. The altitude of a right triangle, triangle ABC. Ooh, let me erase some of this. Okay, intersects the hypotenuse, creating 2 new right triangles, ACD and BCD. Okay, so what it's saying is basically, I have this triangle ABC right here, and I have an altitude that's in the middle of it. Altitude is the line that creates the right angle. So this green line, there's actually 2 of them in this situation. This one is also an altitude because it also creates this right angle. Okay, but if we have an altitude in the middle of our right triangle like we do, so the green line, it creates 2 smaller triangles. This one here, and also this one here. Okay, so we have the big one that I highlighted with the yellow, so that's going to be papa triangle. We have the green one, which is going to be mama triangle, and then this blue one, which is going to be baby triangle. Okay, and all of them will be similar to each other, so here is our similarity statement. Okay, so if we notice, this is a different way of looking at it. We have our big triangle, so this big one here is papa, which is over here. We also have the green one, which is mama, and then we have the red one, which is baby, and they're all similar to each other. So we could say triangle BCD is similar to triangle. We match, B matches with C matches with A, and D matches with D. Is similar to, now I'm going to compare these 2 here. So C matches with B, A matches with A, and D matches with C. Okay, so the altitude of the hypotenuse, so we're going to build our own. So first let's do our papa triangle. So I'm going to highlight the entire thing here. Oops. Okay, so it looks like the right angle sits at S. The tippy top point on my long leg sits at R, and my other short leg angle is Q. So if I erase it, we're going to do mama. Here's my mama with the right angle. The right angle this time sits at T. The long leg point is R, and then the short leg point is S. So I'm going to erase it so we can do baby. Here is baby. And then if I have a right angle here, it automatically means since I have a straight line, I have a right angle there. So the right angle sits at T, the short leg is Q, and the tall leg is S. So if we wrote our similarity statement, we could say triangle RSQ is similar. R matches with R, S matches with T, and Q matches with S. And now my next similarity statement, R matches with S, T matches with T, and S matches with Q. And then we could, if we wanted to, these angles are congruent, my right angles are congruent, and these angles are all congruent. Okay, so geometric mean. This is going to be my geometric mean. Our x's are always sitting across from each other, and then our numbers are going to represent A and B here. So if I zoom in here, this is going to represent A, this is going to represent B. So I would have 9 over x equals x over 4. Okay, these could be flip-flopped. It's going to get you the same thing. As long as your x's sit across from each other, you should get the exact same answer. So if I multiply, I got x times x, which is x squared, 9 times 4, which is 36. Opposite of squaring is square rooting. So we're going to square root both sides to get rid of that squared. Square root of 36 is 6. So when you type it in your calculator, you type in the second, and then you're going to type the x squared button, and then you're going to type in 36 and press enter, and it should get you that. So this is going to be A, this is going to be B, so I have 14 over x is equal to x over 6. Okay, so when I cross multiply, I get x squared equals 14 times 6 is 84. Opposite of squaring is square rooting, so x is equal to, when I type in the second square root of 84, I get 2 square root 21, but I want the decimal. So if I press this button above my enter sign, it's my magic button, it's going to get me the decimal that I actually want of 9.17. So if I move over here, this is A, this is B. So 9 over x is equal to x over 30. X times x gets me x squared. 9 times 30 gets me 270. Opposite of squaring is square rooting. X is equal to square root of 270, which gets me 3 square root 30. I do my magic button. So x is equal to 16.43. Okay, and you'll see why I'm showing you guys the geometric mean. It's going to be like a comparison. It's a proportion. We're going to be setting up the proportions of our mama, papa, and baby triangles in a second. Okay, so identify the following bold segments in each triangle. If it's short leg, long leg, hypotenuse, of which triangle? So what triangle is this touching? It looks like it is touching. It's a side of this one, and it's also a side of this one. Okay, so it's a part of mama and baby. For baby, it's going to be the long leg. And for mama, it is the short leg. Okay, because long leg of mama would be here. Hypotenuse, always remember, sits across from your right angles. So my next one, if I highlight, looks like it's a side of baby. And that is sitting across from my right angle, so it would be the hypotenuse of baby. But does it touch any other side? If I turn my highlighter, it also touches the big triangle side, so papa. And it is the short leg on papa. Okay, if I highlight, it looks like it's touching mama. So for mama, right, it is across from the right angle, so the hypotenuse. And if you look, it's also papa. And it is the long side of papa. This is the short side. Across from your right angle is the hypotenuse for papa. Okay, this one, it looks like it's touching baby. And it's the short side of baby, because my right angle is right here. And it's not completely touching mama or papa, so this one is just baby. Okay, this one is touching mama, and it's the long side. Okay, my right angle's here, so that would be hypotenuse. This is my shorter side. It is not touching the full side of papa, so we can't say it's touching papa, and it's also not touching a full side of baby, so it's just mama. Okay, this one you can see it's papa and hypotenuse, because it sits across from papa's right angle. And since it's completely touching baby and mama, we cannot say is baby or mama, because it's touching more than just baby. It has to only be touching that side for it to be working for baby and mama in this one. Okay, so corollary 1, the length of the altitude is the geometric mean of the two hypotenuse segments. Okay, so this is if you're given or missing an altitude. So this green line here. Okay, and what we're going to do is basically a comparison of the triangle. So that altitude, that green line, touches this, and it also touches this. So when we set up our geometric mean, we're going to use these two lengths here that were given to set up the mean, because it's touching both mama and baby, so we want to include the lengths of both mama and baby triangles. So here's our first example. So when we set up our geometric mean, our altitude is always going to be what the x's were when we were doing the geometric means. Okay, so if I look, I'm going to highlight. It is touching baby and mama. So I need to include baby and mama when I set up my geometric mean. So if I do y on top, it's touching baby, it's also touching mama, and my altitudes always have to be sitting across from each other. Whatever my altitudes are, whether it be a letter or a number, they always have to be sitting across from each other, and the two other legs will be sitting across from each other. Okay, so when I cross multiply, I get y squared equal to 8 times 2 is 16. We square root both sides to get 4. Okay, so if I highlight, it is touching baby and mama again. So when I set it up, I got y over, we could do baby equals mama over my altitude. Altitudes always sit across from each other, so we can cross multiply. 6 times 14 gets me 84. Opposite of squaring, we got a square root. And then I want the decimal of it, so y equals 9.17. Okay, this time my altitude's 10 and not y. So I got 10, it's still touching baby and it's still touching mama, and my altitudes are still sitting across from each other. I said it could represent a number as well. Okay, so 10 times 10 gets me 100. 4 times x gets me 4x. Divide by 4, x is equal to 25. So my altitudes sit across from each other, and the two legs that altitude touch sits across from each other. This time it just represented x. Okay, here's our other corollary. The length of each leg of a right triangle is the geometric mean of its hypotenuse in the segment adjacent to the leg. So this is if you're given or missing a leg. And I'll show you what it looks like. Okay, so for my first example, we're going to find x first, so I'm going to highlight x here. Okay, x is touching baby, and it's also touching papa. It's the full length of papa too. So let's set it up. I have x over, it's touching baby, it's also touching papa. Papa's this entire length, so what I need to do is 1 plus 9 over my x again. Okay, what's missing is these x's here. So when I add, 1 plus 9 should be 10. X times x gets me x squared. 10 times 1 gets me 10. Opposite of squaring is square rooting. Square root of 10 in decimal is 3.16. Okay, so now I'm going to erase this and we're going to do y. Here's y. Okay, this is touching papa. Come on. And it's also touching mama. So when I set it up, I use papa and mama. So y over, let's do mama. So the length of mama here is 9 equals papa, the entire length. So 9 plus 1 gets me 10. And then I have y again, the missing leg. So I got y squared equals 90. Square root both sides. Square root of 90 in decimal is 9.49. Okay, so if we're finding x, it is touching baby and papa. Baby and papa. So we're going to do x over the leg of baby equals papa's length, so 14 plus 6 is 20, over my missing leg. X times x gets me x squared. 6 times 20 gets me 120. Opposite of squaring is square rooting. So x equals the square root of 120 in decimal, 10.95. So now when I highlight y, y is touching mama and papa. So I got y over mama's length, which is 14, equals papa's length, which is 6 plus 14, which is 20, over my missing leg. So y squared equals 20 times 14, which is 280. Opposite of squaring is square rooting, so it just becomes y. Square root of 280 in decimal is 16.73. Okay, we're missing x, y, and z, so let's find our outer legs first because that's what we've been doing recently. So we're going to find x first. So it is touching mama and papa. So I'm missing x. Mama's length is 12, which is equal to papa's length, which is 12 plus 3, which is 15. Cross multiply, I get x squared equals 12 times 15 gets me 180. Opposite of squaring is square rooting, so x equals the square root of 180 in decimal, 13.42. So let's change color so we can do y here. That's y. So it is touching baby. I'm going to zoom in here. And it's also touching papa. So I'm missing y. Baby's length is 3. Papa's length is 12 plus 3, so 15. Cross multiply, I get y squared equals 3 times 15 should get me 45. The square root of 45 in decimal is 6.71. Okay, now we're doing z, and we're missing the altitude. So here is z. So I do z over, it looks like z is touching mama and baby. So I'm doing mama and baby's length. So z over mama's length equals baby's length over what's still missing. So I get z squared equals 36. Square root both sides, so z is going to equal 6. So you're trying to figure out what lengths it's touching in each triangle, and that's what you're setting up the geometric mean as. Okay, use the figure below to complete each proportion. Okay, remember the ones that sit across from each other, there should always be a set matching. So if you don't see, if this set doesn't match, that means this set will have to match. So when I rewrite it, this should be R. I'm going to change colors. Okay, if this set doesn't match, that means this set has to match, so this should be Y. This matches, so we're going to have to find the opposite. This set doesn't match, so this set should match, so this needs to be Q. Okay, this doesn't match, but this will have to, so this needs to be R. Okay, this set matches, but this set doesn't have to, so we're going to have to find the missing ones for those. Okay, so if I look, I'm going to highlight Q. So Q is the thing that supposedly is missing. So Q, it looks like, is touching Papa and baby. So we need the lengths that match with Papa and baby. So it looks like T is baby's, so then I need that same spot length except for matching Papa. Papa is X, so this needs to be X here. Okay, so when I erase it, my next set here, if I highlight it, it looks like we have R. So if R was missing, what we do have is X. Okay, so R right now is touching Mama and Papa. So it has X of Papa, but we need Mama's length that we don't have, matching the same spot. So we need S for this one. So it's like how you would set up the geometric mean if we are giving you part of it. Okay, error analysis. A classmate wrote an incorrect proportion to find X. Explain and correct the error. So X right now, if I highlight, boop, is touching baby and mama. So if I set it up, I got X over baby, which is 3, equal to mama. I don't know mama. I know this entire length is 8, and this teeny portion is 3. So if I do 8 minus 3, I should get what I want left, which is 5. So mama is 5, and then we match our X altitude again. So it looks like what they did was they used Papa's instead of Mama's.